Hey everyone, and welcome to This Explainer. Today we're going to explore how one man's lifelong curiosity completely revolutionized our understanding of the universe. We are, of course, looking at the extraordinary life and mind of Albert Einstein. And you know, this isn't just a story about complex math. It's really a story about a fundamental shift in how humanity perceives reality itself. And it all started from a place of simple, everyday wonder.
We kind of have this tendency to think of genius as something a person is simply born with, right? Like they just arrive fully formed and ready to change the world. But what if it actually starts with a relentless, incredibly simple question about how the world works? From his earliest days, Einstein was a profoundly curious kid who constantly wanted to understand why things happened. He'd spend hours just sitting and thinking deeply about the world around him, pretty much proving that asking why is the absolute foundation of brilliant discovery.
All right, let's dive into Section 1, The Invisible Force, a Child's Fascination.
So to see where all that curiosity really began, we have to travel back in time a bit to late 19th century Germany, specifically Ulm, where Albert Einstein was born on March 14, 1879. One day, his engineer father Hermann showed him a completely ordinary pocket compass, but young Albert was absolutely mesmerized by it. He just stared at it, completely fascinated by the fact that the needle always pointed north, pulled by this invisible force. Later in his life, he actually described this exact moment as one of the most important inspirations of his entire childhood. It literally sparked his lifelong desire to explore the hidden mysteries of nature.
Now, here's a really fascinating contrast for you. Because he actually started speaking a little later than most children, some people around him honestly thought he might not be very intelligent. But in reality, his silence was just a sign of a deeply thoughtful kid. He was constantly questioning and analyzing his surroundings, quietly processing the world in ways that other people just couldn't see yet.
As he grew up, his path was anything but conventional. I mean, he excelled in math and physics, for sure, but he actively disliked any subject that relied on rote memorization. He was constantly challenging his teachers, which, as you can imagine, caused some friction. Eventually, he studied at the prestigious ETH Zurich in Switzerland. But get this, after graduating, he really struggled to find an academic job. He finally ended up working at the Swiss Patent Office, examining new inventions. And honestly, this was a massive blessing in disguise because it gave him the quiet time he desperately needed to just sit and think deeply about complex scientific problems.
Which brings us to Section 2, The Miracle Year, Rewriting the Rules of the Universe.
All those hours of quiet contemplation at the patent office were about to erupt into a total scientific revolution. The year is 1905. And this year changed his life and our world forever. It was so profoundly impactful that scientists pretty much universally refer to it as his miracle year.
And it's easy to see why. In that single calendar year, while still working his day job as a patent clerk, he published 4 groundbreaking scientific papers. These weren't minor updates either. They covered the fundamental nature of light, the actual existence of atoms, and the dynamics of motion. He completely stunned the scientific community and single-handedly shifted humanity's understanding of the cosmos, basically laying the entire groundwork for modern physics all at once.
Moving right along to Section 3, Warping Space and Time, the Theory of Relativity. Building on that insane momentum, he dropped his most famous achievement, which completely shattered how we view our everyday reality. The theory of relativity proposed the unbelievable idea that space and time are not the same for everyone. It means the way you experience time literally changes depending on your speed. Imagine a clock on a high-speed spacecraft. It would actually tick differently than a clock just sitting still on Earth. At the time, this sounded like straight-up science fiction, but later experiments proved that his predictions were absolutely spot on.
And this brilliant breakthrough culminated in what is arguably the world's most famous formula: E equals mc squared. This little equation was a massive revelation. It proved that matter and energy aren't separate things at all, but are actually just different forms of the exact same underlying stuff.
Just breaking it down really quickly, E stands for energy, m is mass, and c represents the speed of light. By linking these 3 properties, this formula became one of the foundational pillars of modern physics. It totally flipped how scientists understand the fabric of the universe, proving that a tiny, tiny amount of mass can actually be converted into an immense amount of energy.
Okay, let's look at Section 4, The Real Nobel Prize, 1921.
So, with all this groundbreaking work, you'd naturally assume relativity was what won him his greatest award, right? Well, actually, scratch that. History has a fun twist here. He didn't win for relativity. He actually won the Nobel Prize in Physics in 1921 for a completely different discovery, his explanation of the photoelectric effect. This was a critical piece of the puzzle regarding how light interacts with matter. And what's really amazing is how relevant that specific discovery is to you right now. His work on the photoelectric effect contributed directly to the development of solar panels, the digital cameras we use every single day, light sensors, and just countless modern electronic devices. His theoretical physics literally translates into technology you're probably holding in your hand right now. Which leads us to Section 5, a lasting scientific legacy beyond the physics.
Looking at his later life, we can see how his impact expanded way beyond theoretical equations on a chalkboard. During the 1930s, as the Nazi regime gained power, conditions in Germany became incredibly dangerous. Einstein made the very difficult choice to escape his homeland and relocate to the United States. He settled in Princeton, New Jersey, where he spent the rest of his life continuing his research, remaining one of the world's most respected figures until he passed away on April 18, 1955, at age 76.
But, of course, his passing was not the end of his story. His mind still shapes our daily reality. I mean, he gave us the foundation for atomic energy and deep space exploration. And remember the theory of relativity we talked about? Without that theory adjusting for time differences, the GPS satellites that give your phone accurate location data simply wouldn't work.
Yet despite his massive, world-altering intellect, he was known for being remarkably humble. He loved playing the violin in his free time, he was a huge advocate for global peace, and he left us with this incredibly powerful thought: imagination is more important than knowledge. He really believed that while knowledge is limited to what we currently know, imagination encircles the entire world.
So as we wrap up this explainer, I want you to think back to that little boy in Germany, completely captivated by the invisible force of a simple compass. He followed that curiosity to transform our entire understanding of existence. So ask yourself, what invisible forces, what everyday mysteries are just waiting out there for your own curiosity to uncover? Never stop asking why. Thanks so much for joining me, and keep exploring.